Hello all, in this video we will learn about transformers and the connect between the transformers and large language models. This is only the part 1 video where we will get to understand the foundations of transformers, and we will also get to learn about how to code the large language models using Groq API for summarization and code generation task. In the part 2 we will focus on how to understand the deep math that is involved in large language models. Okay, so what is a transformer? So transformer is like the foundation on which the large language models like GPT, Llama, and Mistral is built with. So you can think of this like it is the core and heart of large language models. So here, this is the transformer architecture. So that was introduced by Google in the year 2017. Don't worry, you will not understand if you're not understanding at this point of time the components of what is involved in the transformer. So, but at the end of the part 2 video, you should be able to understand each and every component of this transformer. So in this is the transformer is nothing but you can think of like a deep learning architecture that is designed to process text efficiently using a mechanism called self-attention. So self-attention is the core idea that they actually introduced in their transformer paper. So that's why they also named the paper as "Attention is all you need." So this attention mechanism focuses on capturing the relationship between the words, because all the applications that process human languages in the form of text and speech, they need to interpret the deep meaning behind the text and speech. So this self-attention mechanism is actually helping the systems to understand the relationship between the text and the speech. So that's about the transformer. So how these transformers power LLMs? So as we said earlier, so this is powering LLM through the self-attention mechanism. We will learn about how the self-attention works deeply in the next part, but you can think as of now, this self-attention helps on focusing on the important words when a sentence is given to a system. So maybe you can think of a scenario. So when we are giving a prompt to a chat GPT, so you can very well notice that the chat GPT is only focusing on certain words given in your prompt. So that's what self attention means. At this point of time, it is enough to understand at this level. And yeah, so parallel processing, unlike RNN, until 2017, the recurrent neural network was ruling the natural language processing domain. But the problem with RNNs is that, like at a single time step, let's say we are processing the sentence, the cat is black. So either we wanted to understand the sentiment of the sentence, or we wanted to translate whatever may be the task behind this. So we are processing this sentence. So what happens in RNN at times a time step T1? So this the is given passed into the RNN. So and then in the second time step, so the this information of the is also passed as a history to the next level, and along with the second time step input cat. And then it is a sequential model. So this is how it just captures the relationship between the words sequentially. But the problem with RNN is that at a time step, as a single time step T, it can only process one word. But what is the disadvantage behind this is that, like with the computational resources that we have in terms of GPU, so this is not right to process a single word at a time. So what transformers gave the power to the large language models is that at a time it can in parallel process all the words simultaneously and capture the relationship instead unlike RNN. So that's the power that it is giving to the large language model, and multi-layer stacking. So these deep neural networks like try to understand the relationship between the text in multiple times and through multiple layers of the network. So the architecture. So that's how they can understand the meaning of the text. But we humans are capable of understanding the natural language words in a different way. So our human brain is way, I mean, So we are more capable than how these large language models are able to understand, but these are slightly mimicking the way the human brain is understanding a particular language. So yeah, so the let's say, for instance, to make this point even more clear, so let's say I'm uttering the word food. So the moment I uttered, so many would have actually visualized the food and the moments that you created with food. So that's how the human brain is capable of like interpreting a particular word. So when you even talk of a sentence, like let's say we are throwing a sentence like, what is the cost of apple? So the human brain can very much understand that, like, what cost of apple we are talking about. Like, are we talking about the fruit apple or the Mac apple? So because like the context we can easily capture, but that's not the case with these systems. They need to understand in a multi-layer level of understanding. So that's how they are mimicking the way we humans are understanding the natural language. Pre-training and fine-tuning. Yeah, so the pre-training is already done by the large enterprises. So like when GPT 3.5 was released by OpenAI, so it was already built with large unlabeled corpus, and so it was released to us. But fine-tuning is a different case. We are given with these large language models pre-trained by the large enterprises, but what we can do, so like we, as in like I mean the students, the researchers, or the small enterprises. So we can come up with a small labeled corpus and we can fine tune. So fine tuning involves two different things. So either we can fine tune to make the large language model to work for a particular domain, or I mean, by making it to work for a particular task. That it is primarily making it to work for a particular task like chatbot summarization or code generation or question answering, machine translation, lot more. So these tasks can also be aligned to a particular domain. So that's what I'm talking about. So fine tuning means making it working for a particular task and making it aligning to a particular domain. So aligning to a particular domain is like it is user specific. It can also be generic, but mostly it is done that way. Okay, so now we know what is a transformer and how it can actually power the large language models. We'll also get to understand what a large language model means. Right. So it is the advanced AI system built on top of transformer. So as we said, like transformer is the core and heart of large language model. So what a large language model? It is primarily a next sequence predictor. So if you look at the large language model like ChatGPT. So the response that you see is the sequence of your prompt, and each and every lines in the response is the sequence of the sentences that has generated. So the very easy next sequence predictor that we can visualize is a Google search engine. Um, so before so when the transformers was introduced, the next sequence that was predictor, so that is the BERT model, was actually integrated in Google search. So it is able to predict the next words. So that's how we should understand. So all these large language models are next sequence predictor. So what I'm trying to convey here is that all these large language models are primarily a next sequence predictor. The sequence can be a word, as we see in Google. So in Google, we see it as a next word prediction, right? Like, but in DeepSeek or ChatGPT or Gemini, so the sequence is nothing but the set of sentences or the set of paragraphs that we see. So depending upon the capability of large language model, the sequence will vary. So that's what I'm trying to convey. Okay, so when a large language model is actually becoming built for predicting an extra sequence in this journey, it becomes the language expert. So that's what we need to understand, because when someone is able to predict the next sequence, then they are that inherently what it means is that they can understand the grammar, so that is the syntax of the language, and also the complex hidden meaning of the language. So that's how we can visualize we can understand the next sequence prediction capability of these large language models. So it is very well in tune with the human beings also. When a particular person is able to predict the next verse, next word or the next sentence in a given particular language, then he or she is capable of understanding the grammar or the meaning of the particular language. So that's what it means. So, hope I made the point. So here, okay, so when this capability is built with a large language model, then on top of that, we can build a number of applications. So that is the fine tuning that we talked earlier. So when someone is able to understand the grammar and the meaning of a particular language, then so let's talk about the person first. Like when someone is able to predict the next sentences or words in a particular language, then he or she can actually summarize in that particular language, or can answer any question if at all they know in that particular language. If they know two languages, then they are capable of doing translation. So the same way with these large language models too. So when they are primarily a next sequence predictor, so they can also be fine tuned for doing these type of tasks. So in this fine tuning journey, as I said earlier, so they can also become a domain expert. So for instance, if you are building a summarization for healthcare text like discharge summaries, then it becomes a healthcare expert. So if it is done for if it is meant for machine translation, so it becomes a localization expert. So what I mean is that like these tasks can be aligned to a particular domain like fintech or healthcare or educational domains, like whatever it may be. Okay, so we now know what is a large language model, but this slide was taken from Chris Manning and Dan Jurafsky. So they are Stanford professors. It is taken from their um, website. So this is how they define this language model. So what a language model is, that like you can think of language model as a grandfather or forefather or parent of large language model. So language modeling is a task of predicting what comes next. So this is how it all started. So if you look at this, the student opened there. So what is the next word that it can predict? So this is a math behind this. So this is how they define this. So given the previous set of words, so what is the probability of predicting the next word? Here, the x1 is x2 is students, and x3 is open, x4 is there, and we are predicting the next word. So it is merely the probability. So that means we are actually understanding the patterns, the frequent patterns inside the text. So when we say that like we are predicting the next sequence, we are focusing on the patterns that frequently occur. So this system is called as a language model. Okay, so how that language model became large. So here you see the evolution of large language models. So the first one was the ELIZA, which was released in 1967. So it was merely a pattern recognition based chatbot, so keyword based chatbot. And then you see the RNN and LSTM. So these are neural networks that ruled NLP, natural language processing domain, until 2017. And 2017 is the most important year in this domain, like where Transformers was released. And you see all these like million parameter models. BERT was released by Google, and GPT by OpenAI. Robota was released by Meta. So these are million parameter models that work well for sentence level task. And then the next disruption came in the year 2021, where the OpenAI released GPT 3.5. And after that, so all the models released by the various enterprises are billion parameter models. Okay, so now we get an idea. So what makes these language model very large? So it's the term large means the parameters with which these models are built with. So GPT-3 is 350 billion parameters, and BERT you look at when you look at it is 110 million parameters. What are these parameters? They represent the weights the model learns during the training. What are these weights? These weights, so what is our ultimate aim? So our ultimate aim is to capture the relationship between the words in very deeply. So these weights will have the information between the by information about the words relationship that between the words relationship. So that's what these weights capture, and this is trained during the training process. So during the journey of like this building this basic LLM. So that is this is all happening during the pre-training phase. So when this OpenAI built GPT 3.5, so they would have focused on this weights. Yeah, so the large can also refer to the number of training documents with which, because they are all built with massive training data set, so they can also refer to the training data set. Of course, the weights and the training data set have relation. So the more um, training data set you can have, so the more weights you will actually end up with. So that's how these language model became large. So okay, so we already saw this, like, so once again I will just focus on this so that it is etched in our minds. So the power of next sequence prediction. So that's what I said, like if a model can predict the next sequence of words or sentences or paragraphs, so what it can do, so it can do a translation. So that's what we said, right? Like when a human is capable of predicting the next sequence of words or sentences in a particular language, then they can do translation, summarization, question answering, code generation, chatbots, and content creation. Okay, so this next word prediction is the foundation of LLMs that was built by the large enterprises. So that is done during the pre-training phase. Fine tuning is left to us. So we researchers or students, any SMEs or MSMEs can actually come up with fine tuning the large language models to do it for a specific task. So yeah, so this is WhatsApp. So we use large language models on a daily basis. Like this is all inherent in our daily lives. Google. So I forgot to put a snapshot of Chat GPTs. I'm sorry. So these are the spectrums of large language models that we have. So these are open source and they are ready to use, released in Hugging Face website, so we can use it. So you see these models vary in terms of the parameter size. These are million parameter model and tiny BERT. So GPT versions are from OpenAI, BERT versions are from what Google. Yeah. So this large. So we also have billion parameter models. So what we can do is that we can use these million parameter models because they are very well comfortable in using, and you can even run it in your Google Colab. So if you are fine tuning for a sentence level task, so let's say you're only fine tuning for a sentence level like sentiment classification or sentence level translation, then we can use these million parameter models. When we are looking at paragraph level interpretation tasks, then we need to go for billion parameter models. Okay, so that's what I had to say on the introduction of transformers in large language model. We'll see the codes to understand them better. Okay. Okay, so in this code, what we are seeing is that like we are using Groq platform. So you can go to the Groq platform and grab your API key by just having a Google login, and you can give the key. So Groq is a platform which helps developers to for fast inferencing of LLMs. So without any huge computational resources. So it's as of now free, so you can make use of that. So this is the website from which you can get the API keys. So and this is where we are giving the prompt. So this code is meant for creating a LinkedIn post. So this is what we call it as fine tuning, but I have not given a unlabeled corpus. A labeled corpus. I'm sorry. So, but I'm not training, fine tuning the large language models. I'm straight away using the large language model to do a particular task. So, Here, the fine tuning is not necessary. So when you need to give a small documents and fine tune is that, like when the basic LLM is not having that capability, then you can, it's not aware of a particular domain, let's say healthcare, or if it is not able to do that particular, if it is not cognizant in that particular domain, then you can build a small training data set and fine tune it. But here, since Llama is already capable of creating a LinkedIn post, maybe like I can make it better by having a fine tuning. But for this explanation purpose, I'm just giving a prompt. So write an engaging LinkedIn post explaining transformer in AI. That's the prompt I gave. So we are calling this, we are using this Llama 8B model. And so this is the maximum tokens that we set. So we are limiting the response length to make it far. So you can actually vary this length depending upon the requirement that you have. Okay, so now this request is posted to the Groq APIs and the response is obtained in the JSON format. So I've already run this code. So I'll put this code link in the description. So I've given you view permission. So all you can do is that, like, you can save a copy in Drive. It creates a copy for you. You can edit it for your further use. Yeah, so now a copy is created. So you can edit that code. So this is the small code that I wanted to show how a Llama can be fine-tuned for a content generation. So we are using the so when we wanted to create those kind of applications, so customize those applications. Of course, ChatGPT can do this, but if an enterprise is or a researcher is interested in customizing these LinkedIn posts in for user specific post generation, so we can fine tune it or we can release an app. Yeah, so the other use case that I have is the code generation. So same again, like I've used the Llama 8B. So similar way, so I've given you can give the API key. So I gave mine. So you can grab the API key and you can give. So write a Python function code that calculates the Fibonacci sequence up to n number. So this is the prompt that I gave. So we are calling again the Llama model. And so here we have set the max tokens to be 200. So it's up to the user or based on the requirements. So again, we are calling the API and we are getting the response from the API. So this is the output that we get for the Fibonacci series. So these are the two small codes that I wanted to showcase just to how to understand like how these large language models can be used. So in the part two, we will understand about the math behind the large language models. That is the attention mechanism, how the transformers are encoding the relationship between the language. So that's what I had to say in this part. Thank you so much.